Welcome to the second lesson of week 3 of A-Level Computer Science. In this lesson, we'll look at some of the principles of logical thinking which will help us to write successful programs. In this lesson, we'll actually write a program together that solves a logical problem. We'll look at the inputs and outputs that are required, the decision points, and what the outcomes are of the different logical decisions that we will make. So in this lesson, we're going to write a program to implement a very simple game. And I suggest you write this, follow along, and have Python open separately on your desktop and write the program as we go. Or you might like to just watch this whole lesson through. It's only about 10 minutes and then go back and write the program. Either way is fine. Okay, so to introduce the problem. You've got a fox, a hen, and a sack of corn, and you have to cross the river. If you get all of them across the river to the other side, then you've won the game. The rules are you can only take one at a time across the river. If you leave the fox with the chicken, he'll eat it, and if you leave the chicken with the grain, she will eat it. And you've got to avoid any eating happening. So we're going to begin coding. And as I say, you can work along with me or come back and do this later. We're going to use abstraction, obviously, to simplify the problem down to its bare minimum. And we're going to set the starting values. I've got a way of doing this problem. If you can do it in a different way, of course, that's fine. So what I do is I set 4 variables: the place of the fox, the hen, the corn, and you. And I'm setting them all to false, so we're all on the wrong side of the river. And if I cross the river with any of the items, then I change to the other bank and it becomes true. When all the values are true, then I've won the game. So the first thing I'm going to do, I look at my IPO model. I've got inputs, process, and outputs. Well, just for now, I'm going to forget about the processing and I'm just going to get my inputs and outputs right. The collective name for the inputs and outputs that the user sees and can interact with is the user interface of your program. So I'm going to write my user interface first. So the interface will display on the screen, but it won't do anything because I haven't written the processing yet. Okay, so this is the interface of my program. It tells the user what they need to know, the position of the 4 elements: yourself, the fox, the hen, and the corn. And it lets them choose which they want to take with them across the river, F, H, or C. I've just used the initials rather than the full word to make it easier for the user, so they only have to type one thing. So if you want to just write that code, I'm about to display it on the screen, but if you want to pause the video and try and write that code yourself, please go ahead. Okay, so here's the code that makes that happen. You'll notice I've put it inside a while loop, and the logical test of the while loop is true, and actually that is a never-ending loop. I'm just using that for now. Later on, I'll change it so that when I win the game or lose the game, the loop will stop. But for now, I've just got that endlessly repeating, displaying the data where all the different creatures are, and allowing some input. And I'm storing the input as a variable called move. So now I'm going to write code inside the loop that lets me move the fox. And what I'm saying is, if the input from the user is capital F, then I'm going to output a message: you and the fox cross the river, and then I've just got to change the position of the fox and of you. And this is my first attempt at the code. I've changed the position of the fox and the position of yourself to true. This code will not do. That's because I need to be able to go backwards and forwards across the river. So every time I move false becomes true or true becomes false. I could write quite a complicated nested if structure for that, but here's an easier way of doing it. I just change the position to its opposite, and the logical operator not will do that. It will just reverse the truth value. So the fox place becomes the opposite of what it was. If it's false, it becomes true. If it's true, it becomes false, and your position changes similarly. Okay, so that's a much better bit of code, but I'm still not happy with it. And let's see my final version of this code. I'm going to move across the river whether I take the fox with me or not. Sometimes I'll want to cross the river without bringing anything with me. So I've moved the change of my position outside of the if structure. So each go of the game, my place will change to the opposite side of the river, whatever I choose, whether I take the fox with me or not. So actually, I'm happy with that code now. Right, so what do I need to know and implement in order to be able to take the fox across the river? Well, for one thing, what we've already done, I have to input a capital F, but there's more to it than that. Me and the fox have to be on the same side of the river, otherwise I can't take him across the river with me. So let's write the code to make that happen. At the moment, the code looks like this. If I enter the letter F, me and the fox both cross the river. We've already thought about a reason why that's not right. I have to be on the same side of the river as the fox. So I'm having two tests here. If I select the letter F for who I want to move, and the fox place and your place are both identical, either both true or both false. If both of those preconditions are true, then you and the fox can cross the river. Otherwise, you move on your own. I'm actually going to improve that even a little bit further. I'm going to add an else so that the user gets a message to tell them why they can't move the fox. So I've used a nested if structure. If you enter F to move the fox, if the fox and you are in the same place, then you both cross the river and the fox place changes. Otherwise, an error message will appear. You've entered F, but you are on the different sides of the river, so you can't move the fox. So I'm happy with that code now. So let's analyze the logic of our program. We've got certain preconditions that need to be in place in order to move the fox. We've got certain tests that we need to carry out. And then there's a branching structure using nested if where there are different outcomes. Our preconditions are the user input and our data that we already have in place about what side of the river I am on and the fox is on. My two tests are whether the user has input a capital F and whether the fox and the person are on the same side of the river. And then depending on the outcome of those tests, either both the person and the fox move or you move on your own. So to recap, when we're using logical structures in our programming, we have to identify decision points where the program branches. We have to identify the correct logical tests that will allow us to go along the correct branch, and then we have to work out the different outcomes along the different branches of the program. So now I'm handing this over to you. I'm not going to give you the rest of the program. You've got to develop it yourself. First thing to do is to extend that program so that if they select H for the hen or C for the corn, they're taken across the river in the same way as the fox. What I recommend you use is an elif structure and copy and paste the fox code, but just change fox to hen or whatever. And that's a very quick way of extending the program. And then finally, you've got to get the win and lose conditions for the game. If the fox and hen are left on one side of the bank without you there, then the fox will eat the hen. And similarly, if the hen is left with the corn. So if either of those two events occur, then you've lost the game. However, if all 4 items, you, the fox, the hen and the grain, all have the value true, that is, you're all on the right side of the river, then you've won the game. With all that in mind, let's complete the program. So these are the tasks I'm leaving with you. Extend the program to move the hen and the corn across the river. Set both lose and win conditions. They'll have to be separate variables because they're independent of each other, and set them to false before the loop begins. Inside the loop, add tests for the win and lose conditions, and then make the loop until win is true or lose is true. So you adapt a while loop so that it will continue as long as we haven't got either the win or the lose conditions. And then finally, below the loop, show some kind of a final message to tell the user if they've won or lost the game. So if you can make all of those happen, you've implemented the logical puzzle game. So I'll check this out next time that we meet. So bye for now.